Okay, 9.2, graphs of polar equations. So now we're going to graph some of these equations in the polar mode and kind of take a look at what they look like. So graphing by plotting points. So the first thing for several of these, we will be able to use the calculator. But for these first two, r equals cos theta and r equals sine theta, we are going to need to do these by hand and kind of really dive in and take a look at the values, how to plot them, and what they look like. So graphing by plotting points, think about when you first started learning how to graph lines, when you were maybe in Algebra 1 or 8th grade, and your teacher had you make a table of values. So we're going to do that as we start these. So just like graphing in a rectangular coordinate system, we can graph in a polar system using a table by plotting points and connecting them with smooth curves. So we're going to complete each table, round values to the nearest tenth, and then graph the equation. So the first one we want to look at is r equaling cosine of theta. So remember, r is, when we have things that are equal to r, it is all points that are equidistant from the pole. And this does not have any manipulations to it. It is just cosine of theta. So let's see what this looks like. Now, one thing I am going to have you do is add 0 here, because we're going to start with 0 as our theta value. So remember, this is going to be theta, and cos theta, this is our, right, r equals cos theta, so these are our r values. So as you look at the values that we have 0, we have right here pi over 2, we have pi, we have 3 pi over 2, and we have 2 pi. So those are right on the quadrants, on the quadrant, the axes. So let's do those first. So the cosine of pi over 2, remember cosine is related to your x value. So if you're at pi over 2, the cosine of pi over 2 is 0. Actually, let's go back and do 0. If you are at 0 theta, you have not rotated at all. The cosine of 0, your x value is 1. When you go to pi and you rotate all the way around to pi, your x value is -1, so your cosine of pi is -1. The cosine of 3 pi over 2 is just right there underneath pi over 2, so that is also 0. X value is 0. And then the cosine of 2 pi is right back at 0 theta, and that is 1. Okay? So this might look intimidating, but there really is a pattern that makes this very easy. Next, let's look at the quadrants, because as we know, as you go around the unit circle, the signs of cosine, sine, tangent all change. So as I am in pi over 6 and pi over 3, remember that's in quadrant 1, and cosine is going to be positive there. When I go to 2 pi over 3 and 5 pi over 6, I'm in quadrant 2, and those are going to be negative there. So I'm going to go ahead and put negative signs in there. That's one of the things kids always forget to do, is go back and label their signs, so I'm going to do it first. Then quadrant 3, 7 pi over 6 and 4 pi over 3. Cosine is negative there as well. And then 5 pi over 3 and 11 pi over 6, this is quadrant 4. And cosine is positive. So the beauty of reference angles is that as we travel around the unit circle, we have repetitive numerical values for cosine and sine. So when we are in the first quadrant, the cosine of pi over 6, or 30 degrees, is root 3 over 2. Now we are going to plot this. So when you think about root 3 over 2, how far is that? So for our intents and purposes with this question, we want to convert root 3 over 2 to a decimal. When you go to your calculator and you type that in, you're going to see that root 3 over 2 is 0.9. Now, think about going into the second quadrant with a reference angle of pi over 6, or 30 degrees. Well, that's going to be at 5 pi over 6. So again, even though I'm in the second quadrant, it's still going to be 0.9, but it's going to be negative. The next one with a reference angle, as we move around to the next quadrant, in the third quadrant, reference angle of 30 degrees, or pi over 6, would be 7 pi over 6. And still negative, so that's going to be negative 0.9 as well. And the last one, when I go to the fourth quadrant with a reference angle of pi over 6, it would be 11 pi over 6, so that's also 0.9. All right, now think about pi over 3. That's 60 degrees. The cosine of pi over 3, or 60 degrees, is 1/2. As we move into the second quadrant, reference angle of pi over 3 would be 2 pi over 3, but that's negative 1/2 because we're in the second quadrant. Moving into quadrant 3, 4 pi over 3, reference angle of pi over 3, that would be negative 1/2 as well. And then in the fourth quadrant, 5 pi over 3 would have a reference angle of pi over 3, and that would be a positive 1/2. So now we have our table of values, and we are going to graph them on this polar coordinate scale. Okay, so the first one we have is 0, 1. So I'm going to actually, because I don't go really past 1, I'm going to make my scale to be in fourths, 0.25. So every one is 1/4. So I'm going to go out 1, 2, 3, 4, and right out here is 1. That's going to help us space our graph out a little bit better. Okay, so the first one is rotate theta to be 0 degrees, and then out 1, so there's my first point. Then I'm going to go to pi over 6 and go out to 0.9, so I will be right here. Then I'm going to rotate to pi over 3, and I would be at 1/2, which is just 2 out. Then at pi over 2, I am at 0. So as I begin to trace my curve in the order of theta increasing and rotating, I have this so far. And you really want to connect those curves, those points, in the order of theta. So then we have 2 pi over 3. So I'm going to go to 2 pi over 3. But instead of going out negative 0.5, which would be on the terminal side here, I don't want to do that. I want to go the opposite direction, and that's going to put me down here at 5 pi over 3, and I'm going to go out 1/2 there. Then I'm going to go to 5 pi over 6, which is over here, which would be kind of in the second quadrant. But instead of going out on that terminal side, negative or 0.9, I'm going to go the opposite direction. So I'll be out here on 11 pi over 6, and I'm going to go out 0.9. And then at pi, I'm at negative 1, so I'm going to rotate all the way halfway around, go out to 1, but then I have to reflect back over. So it's going to be right back here where 0 is. And I've actually completed my circle. So now if we go around again, if we keep going, this 7 pi over 6, I'm going to rotate, let me change colors here, I'm going to rotate 7 pi over 6, and then I would go negative 0.9. So instead of going out 1, 2, 3 point, or actually out to negative 0.9, I'm going to go back, and that's going to be that point right there that I already have. Then 4 pi over 3, I'm going to go out negative, I'm going to go out 1/2, but then reflect back over. That's going to be there. And then 3 pi over 2 is at 0. 5 pi over 3 is out here at 1/2. 11 pi over 6 is out here at 0.9. And then 2 pi is back at 1. So it really just repeats again after you get to pi. So really, 0 to pi gives you the complete graph for cosine of theta. Okay. Now we're going to go to r equaling the sine of theta. So same thing again. Let's think about this. I would like you to start with 0. Actually, let's write that on the inside here. And go fill in these values. So again, this is my theta, this is my r value. So the sine of 0 is, remember, these are my y values, so that's going to be 0. The sine of pi over 6, which is 30, is 1/2. The sine of pi over 3 is 60. That's my 0.9, root 3 over 2. The sine of pi over 2 is 1. So remember, this was quadrant 1. Now we're going into quadrant 2, quadrant 3, and quadrant 4. So sine is positive in the first and second. It's negative in the third and fourth. I'm going to put my negatives in there. And you can go do the rest of your quadrantal angles if you want. Pi over 2 is 1. Pi, you're back at 0. 3 pi over 2, you're down at negative 1 for the y. And at 2 pi, you're back at 0. Okay, so if you go back to pi over 6 being 1/2, the next one that's going to be 1/2 would be 5 pi over 6. And then 7 pi over 6 and 11 pi over 6. And we already have our negatives there. Then pi over 3 was 0.9. The next one that would be 0.9 would be 2 pi over 3, and then 4 pi over 3, and then 5 pi over 3. And now we're going to plot this. We're going to use the same scale of 0.25. And so I'm going to go out 1, 2, 3, 4. There's 1. And let's construct our graph. So we're going to start with 0, 0, pi over 6.5, pi over 3.9. So we're kind of going like this. Pi over 2, 1. 2 pi over 3.9. 5 pi over 6.5. And pi is back at 0. And once again, we've completed this circle. So if you look at all the rest of them are going to be negative. So we're going to go to 7 pi over 6, reflect back over, and that's going to be at 0.5 because it's negative, so we'd reflect back over. 4 pi over 3 is negative 0.9, so we're going to reflect back over here. 3 pi over 2 is a negative 1, so we'd reflect back up there. 5 pi over 3 is negative 0.9, so it would reflect to here. 11 pi over 6 would be negative 0.5, it would reflect to here. And then 2 pi is 0. So we actually, once again, have the entire graph completed by the time we get to pi. And then from pi to 2 pi, it just repeats. So there is our sine and cosine graphs. Okay, so now I want to make sure that you, as you're watching this video, if you haven't done so already, I want you to get your calculator, and now we're going to see some of the cool things that your calculators will do when you're in polar mode with some of these graphs. It's really pretty neat. So when you go to your calculator, first of all, change the mode to polar mode. Make sure that you are in radian mode, and put it in zoom square so that the graphs appear without distortion. Remember, your screen is rectangular, so these points are spaced farther apart than these points. But when you hit zoom square, it changes and helps the orientation so that your graph looks like it should. So as you plug these in, r equaling negative 3 cos theta, r equaling 2 cos of 4 theta, 2 plus 4 sine theta, and 0.25 theta plus 0.5. I want you to go ahead and pause this video if you haven't done this already, and just graph these, see what they look like, and make a quick sketch of them. Okay, so hopefully you've had a chance to play with them. Negative 3 cos theta looks something like this. B, r equaling 2 cos of 4 theta. This one is kind of crazy. I'm a terrible artist, but it's these petal things. Yeah, kind of something like that. And then 2 plus 4 sine theta. Something like this. And then we have this spiral for 0.25 theta plus 0.5. Okay, so hopefully you get a chance to play with this and make some really cool designs. But these are the types of things that we see when we're graphing in polar coordinates. Okay, now let's talk about symmetry for just a little bit. Many of the graphs that we have seen up to this point possess symmetry about the x-axis, y-axis, or origin when we're in the rectangular system. So much like knowing the symmetry of those equations helps you graph them more efficiently, if we know the symmetry of polar equations, that is going to be just as helpful. So graphs of polar equations are symmetric with respect to the line theta equals pi over 2, which is like our y-axis, the polar axis, which is like the x-axis, and the pole, which is like our origin. So as we look at this diagram, these are just some examples of symmetry, nothing more. So if you have a graph that has symmetry with respect to the line theta equals pi over 2, it looks like this first box here. The second one, symmetry with respect to the polar axis, in other words, flipping it over what we would think of as the x-axis. And then the third one, symmetry with respect to the pole. So in other words, rotating it 180 degrees or pi radians around the pole, it will look exactly like itself. So those are visually the symmetries that we're going to talk about. Now let's look at some more graphs. Okay, so the next example we want to do is to graph 1 minus 2 cos theta using a calculator and table and identify the type of symmetry. Now I'm going to be honest, there are several ways that you can use the calculator to graph these. So you pick the way that is easiest for you. If you watch a different video or if another teacher teaches it differently, keep in mind there are several ways to do this. I'm going to share with you what works really well for me. And if you don't like it, then you can absolutely come see me and we'll talk about another way to do this if you're not comfortable with this. But what I would like you to do is first we're going to make a table. We are going to let the calculator do the work for us, but we're going to do theta r as our table. And we're going to graph every 45 degrees or pi over 4 radians. If you look at the grid on the right, it's in radians. So we're going to graph every pi over 4 radians. We're going to get a point and plot it. So even though we're going to let the calculator do this work for us, we are going to plot these points by hand. So when you plug into your calculator, you're going to have 0, pi over 4, 2 pi over 4, which is pi over 2. Don't go to your calculator yet, just put these in the table. Then 3 pi over 4, 4 pi over 4, which is pi. And then we're going to have to continue this over here. And we're going to have 5 pi over 4, 6 pi over 4, which is 3 pi over 2, 7 pi over 4, and 8 pi over 4, which is 2 pi. Okay, so what you're going to want to do is go to your calculator. So as we go to our calculator, I want you to go to your table setup. And when you go to your table setup, I want you to start your table at 0. And then your delta table, I want you to put in pi over 4. Now when you hit enter, it's going to give you a decimal, something like 0.7 something. But you know now that your table will count by pi over 4. So when you go to your table to fill in your R values, I might go to all the way down to 2 pi, which is 6.28. We know that pi is 3.14. Pi over 2 is something like 1.5. So these are kind of markers to look for. And so I might go to 2 pi where I see 6.28 and kind of work my way backwards. So 2 pi is -1. 3 pi over 2 is 1. Now, in my notes, I do not have my calculator with me right now, and I have some different values in my notes. I kind of changed gears. So I'm going to need you to be able to go to that calculator and read the other values for the 7 pi over 4, which I'm trying to think if I can, I can't quite remember. Pi was, let's see, the cosine of pi is -1 times 2. That was 3. It should be 3. Pi over 2 was 1, and 0 was -1. Okay, so as we start to graph this, and again, you're going to have some other decimal values in there that I do not have. So you're going to plot those points in addition. So let's go with 0, -1. We all have that one. So 0, -1 is going to be out here. Then you're going to plot pi over 4. I'm not sure what the radius is on that. Then pi over 2 is at 1.5. So if if I go to pi over 2 and, no, I'm sorry, pi over 2 is 1. Then I am going to be right here. Now I know the graph did something like this, so start drawing that curve. And then pi was 3. So if I go out to pi, rotate pi and go out 1, 2, 3, I'm right here. And I know this is going to come over around like that. Again, make sure you graph that 3 pi over 4 in there. I forget what that decimal is. And then after pi, we've got 5 pi over 4, so plot that point. Then 3 pi over 2 is 1. And 2 pi is back at -1, and I know it comes up around like this. Okay? So there is 1 minus 2 cos theta. So if we look at that graph, what type of symmetry does this graph have? Well, if I flipped it over horizontally, it would be right on top of itself. So this has symmetry in the polar axis. And if we look back at example 1a, what type of symmetry does that have? So we're going to go back to 1a, which is right here, and this also had symmetry in the polar axis. So, label that. So if we complete the following statement, the graph of a polar equation is symmetric with respect to the polar axis if it is a function of, this would be cosine. So now we kind of see that cosine is going to give us symmetry in the polar axis. All right, let's look at example 3. So in example 3, we have r equaling 3 plus the sine of theta. So again, make sure you're in polar mode, and you're going to want to put in R1 3 plus sine of theta. Using a calculator and a table, identify the type of symmetry. So once again, we're going to make this table of values, and you can just keep the same table, theta and r, and go by 45s. So 0, pi over 4, 2 pi over 4, which is pi over 2, 3 pi over 4, 4 pi over 4, or pi, theta and r, 5 pi over 4, 6 pi over 4, which is 3 pi over 2, 7 pi over 4, and 8 pi over 4, which is 2 pi. Okay, so again, in my notes, I don't have them by 45s. I actually only have the quadrants, but from your calculator, once again, you can get this. So don't forget, 2 pi, go to that decimal 6.28. Pi is at 3.14. Pi over 2 is 1.5. So I have that 0 goes with 3. Pi over 2 goes to 4. Pi is back at 3. And 3 pi over 2 is at 2. And 2 pi is 3. So at 0, we have 3. At pi over 2, we have 4. So I'm going this way. As I go around with theta, at pi, I'm back at 3. At 3 pi over 2, I'm at 2. And at 2 pi, I am back at 3. Oh. So obviously, the more points that you graph, the more accurate your equation or your graph will be. Okay. So if we look at this graph, what type of symmetry does this graph have? This would be reflected over the line theta equals pi over 2. And if we look back at example, it should be 1b. What type of symmetry does this graph have? So 1b was this one right here, and that was a sine curve. And this also had symmetry in the line theta equals pi over 2. So if we complete the following statement, the graph of a polar equation is symmetric with respect to the line theta equals pi over 2 if it's a function of sine. Okay, so this is how we graph polar equations. If you want to go look at some more graphs, their names and some different ways, some different curves that you can make, you would go to page 546 in your textbook.